Alright, so last time we were using those log properties to put expressions together into one log. Doing the opposite today, we're going to be expanding them. So real quick, let's go ahead and review what those properties are. So last class we took something like this. And if you remember the properties, you don't need to write them down again. I'm just going to review it though real quick. And we can compress those down into one expression. Okay, but today we're going to do the opposite. We're actually going to go that way. We're going to break it up. We're going to start with it as one log, and then we're going to break it up into two logs. Okay. Another one we looked at last class was this one. And with that one, we saw that that can be written as one log where you are dividing. Right? Once again, we're working backwards on that one today. We also saw kind of screwed that one up. Let me back up a little bit. So we saw that if you have a log being multiplied by a number, you can rewrite that as the same expression, but with that number as an exponent on the argument. And once again, we'll be working backwards from that today. So same stuff. Probably be a short lesson. We'll see. Depends on how much help you guys need. But that's pretty much it. We're just finishing up what we started last time. Okay, so let's go ahead and start with just doing a couple of different examples. Okay, so what we want to do is the directions are going to be expand the expression using log properties. So I'm going to back up for a second here. Today we're looking at this. We're starting here, right? So what do you see on that side? Do you see a rule 1, 2, or 3? See a 2, right? Fractions there. Do you guys also see a rule 3? Exponents? Let me show you again. See how there's exponents there? Okay. So last time, remember what we said last time when we were putting them together into one log? We said do the power rule first. Remember that? And then do the other rules. Well, when you're going the other way, it's opposite. So we're going to do rule 2 first, and we'll do the power rule last. So let me show you what I mean by that. So the first thing I'm going to do is I'm going to write this as 2 separate logs. One where the x to the 6th, and the other one has a y to the 4th, and there's a minus between them, right? That's the rule. Working backwards. And now we can see, I'll label that as rule 2. And now we'll go ahead and apply rule 3, which according to rule 3, if we're working backwards, we start with a power here, right? what we're going to do is we're going to take that power off and put it in the front as a multiplier. So I'm going to take that 6 and I'm going to put it in the front of the log as a multiplier. Same thing over here with the 4. And that's as far as we can go with it. Okay. The last one? Okay. It's supposed to be a time symbol. I got a little carried away with my time symbol there. No, you missed the last line there. You missed this one. Alright, so what rule are we seeing there, guys? See the first rule, right? Because we got that multiplication, and then also the power rule again. So for rule 1, we're going to write 2 logs, right? We're going to split up those 2 things that are being multiplied. And with rule 1, they're being added. Okay? So that's rule 1. And then we get to do rule 3 again. Nothing new there. Where you take the power and you put it in the front. Just want to throw a couple at you here before we take it up a notch. Alright, try that. Alright, so there's our answers. So for this one, it's m and n are being subtracted, right? Because we're dividing them. And then the powers go in the front of each one. So it would look like that. Notice that the m, the one on top, comes first. The n, the one on the bottom, comes second. That's important. You've got to get the order right on this. Alright. So we're going to just kind of put some variations on all this stuff today, some different things that you might see as you're doing the problems, but that pretty much sums it up. So let's go ahead and take a look at some weird variations. You don't have to title it this, I guess, if you don't want to, but I'm going to call it weird variations. Things to be aware of. We saw this one. You guys kind of struggled with it last time. No. I'm doing this wrong. I'm sorry. Back in it. There we go. Okay, so basically, what do you do with square roots? That's weird variation number 1. How are we going to handle the square roots? Well, the same way we've been handling them now for the past couple of weeks. You're going to change it to a power, right? So that's a half power. So that you guys kind of are visual. There's an invisible 2 there, an invisible 1 there. Okay. All right. So what rule can we apply here? We would apply rule 3. The one where you take the power and you put it in the front. Right? Now just so you guys know though, sure does go up a lot. I'm pretty sure on your tests, if you're on a multiple choice test, they will write it like this. Okay? They're just going to put the log over 2. And we talked about that last time a little bit. What else is another weird variation? Let's look at another one here. Probably more than one way to handle this one. I can think of 2 ways to do it, but I think I'm going to go with what seems to me to be the most direct. I'm gonna. So you guys, what you're noticing here is that we don't have just a letter with a power, a letter with a power. We have that, but we also have another power out here, right? So what you're going to do there is, my advice would be to go ahead and distribute that power in using the power rule first. Like that, and then from there use the log rules. Okay, so we have here rule 1, right? We could write that as log base 3 of M4 plus log base 3 of N8, and then we can throw the numbers to the front using that 3rd rule. Okay. Let's take a look at 2 more types of problems. Tumas. All right. How about all right, so we have the square root here, right? So first thing we can do there is we can change that to a power. That's pretty doable, I think. Nothing too amazing there, but notice I'm going to put that power just on the y and the z there. So it would look like this. So you could think of these as having like powers of 1, and then we distribute in. I'm going to give you guys a second to write, and then I think I'll say all that again because I just did a couple of things there. I want to make sure you guys got it. All right, so first of all, I took this, right, and I change that to a power of a half. And then you can think of those as y to the first, z to the first, and then doing the same thing we did on example 2, you can multiply that power in. Half times 1 is a half. So you end up with y to the half, z to the half. It just basically means you're taking the square root of y and z. So that's kind of like what we did on number 2 and 1 put together, changing it to a power and distributing it in, right? But now here's kind of the new thing here. We have 3 different variables. All of them are connected by multiplication, right? How many logs am I going to get? You're going to get 3 of them. And all those logs are going to be connected by what? Plus or minus? Pluses, right? Because we're multiplying. I wrote that weird, but I'm supposed to say a half. And that's supposed to be a z. Fix that real quick. Okay. So that's kind of the new thing, right? Now, using rule 3, I can throw that to the front, right? Same thing here. But on your test, it's not going to be written like that, right? It's going to be written like this. Log base 3 of y over 2 plus log base 3 of z over 2. And that would be the final answer there.
Could they just like put a whole line under both of those 2 last ones and put this in?
Yeah, you could just like have log plus log and the whole thing over a common denominator. I'm pretty sure on the test it'll be written like this, but technically what you're suggesting would be a good answer. All right, so let's review some of the weird things before we do one more weird thing. So first weird thing we dealt with was square roots, right? When you got a square root, that's a fraction power. When you put it in the front, you're going to write it like that. Second, when you have your expression being raised to a power, you distribute it in by multiplication. And then when you have more than one variable, you just kind of, you have however many variables you have in there or terms, that's how many logs you're going to end up with in the end, right? We have x, y, z. So I ended up with a log for x, a log for y, and a log for z. Okay. I'll throw one more at you before I let you guys practice some, and then that will actually conclude our lesson. So this is kind of like the mother lode of the problem. It kind of pulls everything in together. Ready? Let's say this is 2, and let's say we have x over y square root z. And what I'll do is I'll just let you guys kind of, if you're brave enough and willing enough to walk me through it here. What are some things that we can do? Okay, cool. We could start by separating the 2 logs. That would work. So how would we do that?
You would have log 2x minus log y square root z.
Okay, I agree with that. I like that. Log 2x minus the bottom, right? Log 2 y square root z. Cool? All right. Thank you, John. What else can we do here, guys? Any other thoughts? Was that a? No. Okay.
Can you turn the square root into
Good. So we can turn the square root into an exponent of a half, right? Good. Anything next? Anything else? Mm-hmm.
Separate the y next.
There you go. The y and z?
Yeah.
Good. Now this one you're going to want to be careful with. Let me show you something. Just bear with me for a second, but you're right. We do want to do that. Put that in parentheses, and I'll tell you why in a second. So what Melanie just suggested to me was we could separate the y and the z there, right, into two separate logs. So whenever you separate two logs that or when you separate a log that has its argument with two things being multiplied, we use addition, right? Feeling like I wrote that weird. There we go. Good call. But notice it's still in parentheses. Now, what is that going to affect? Yeah, you guys see that minus there? You're subtracting both of them, so now they both become negative. So it'll look like this. Okay, we're almost done. One more thing that we can do there. Okay. Uno más. Put the power in the front, right? Rule 3. Throw that to the front, and then we're done. So now, when it's in the front, it would be a half, right? But how am I going to write it instead? Just put the whole thing over 2. Okay? So at this point, you guys might be asking yourselves, how do I know when I'm done? You're done whenever you have a log with a number and a variable only. Right? The 2 is not part of that logarithm. It's dividing it, but it's not really a part of it anymore. So as soon as you get just your log with your base and then the argument there, which is a variable or number, you're done. Okay, so the idea is to completely separate everything. So there you guys have it. I'll throw a couple at you guys to mess around with. See how you handle them. We'll start off with just a couple of easy ones. Make yours a cube root. I guess we can make this a little more interesting.